Now we will review the steam mode. When the mode switch is turned to steam, combi, or hot air, the mode switch sends 24-volt DC return to many components in the unit, and we call the output the oven on signal. Here, the mode switch is turned to steam mode. First, the steam signal from the mode switch is shown, then the oven on output. Let's begin at the lamp triggered by oven on. The power lamp is referred to as DS5 on the diagram. It is located in the upper right-hand corner of the control panel. When the mode switch is in combi, steam, or hot air, the power light illuminates, confirming the oven on signal. Next, we will review the relay board response to the oven on signal, beginning with the boiler pilot enable. The oven on signal enters the relay board at J1, pin 1. It triggers outputs at J6 pin 3 and J4 pin 3. J6 pin 3 is sent to the boiler high limit. The boiler high limit is indicated by SW4 on the diagram. It trips at 240 degrees Fahrenheit. The body of the high limit is located directly behind the control panel, and the capillary enters the boiler on the side. The purpose of the high limit is to disable the boiler pilot, which ends the main burner flame if overheating occurs. A cause for this issue is frequently lime scale. As seen here in the float canister, the scale prevents the floats from closing and sending voltage to the relay board. If the low float does not report a low water condition, the boiler heat enable is not stopped by the logic board because the low water signal is not present. The water continues to diminish as it boils away and dry fire condition results. The boiler limit thermostat registers a temperature exceeding 240 degrees, and the high limit's manual reset button pops out. When the limit trips, the output to the module is stopped and is sent out the normally open contact of the limit to the relay board. The MV signal is lost at the relay board when the high temp limit stops feeding the module. The boiler heat output is lost, and the new signal from the limit indicating boiler over temp is passed to the logic board from J2 pin 4. At the logic board, it enters at J4 pin 5 and triggers LED 7. To solve this problem, we delime the floats and reset the boiler high limit. Scale in the floats can also cause the floats to stick closed and the water overruns into the oven cavity. If water level issues arise, the first place to investigate is the float canister. In normal circumstances, the limit passes 24 volts AC to the boiler ignition module. The boiler ignition module can be either a Johnson or a Fenwal. They operate in the same way, but the Fenwal has a diagnostic LED to aid with troubleshooting. The boiler ignition module is shown as U9 on the wiring diagram. The boiler ignition module is located above the two hot air ignition modules. The sequence of operation for the ignition module begins with 24 volts AC arriving at terminal number 2. The module then performs a self-check and if it rectifies a pilot prior to PV output, the module locks out. If no pilot is rectified, the sequence continues with the trial for ignition. The module outputs 24 volts AC from PV1 to the pilot gas valve solenoid and a high voltage, low current spark signal to the pilot. It will only continue with trial for ignition for 50 seconds. It will move on if a flame is rectified, and if no pilot is sensed, it will lock out after 50 seconds. The module will not retry unless power is reset to terminal 2. During the trial for ignition, gas and spark are present at the pilot assembly, lighting the pilot. The lit pilot contacts the flame sensor, and as long as the module is well grounded, microamps arrive at terminal 4 sense. If the microamps are greater than 0.15 for Johnson or 0.3 for Fenwal, the trial for ignition ends and the MV output is enabled. 24 volts AC is sent out from terminal 3 as long as the pilot remains rectified. On the diagram, the module output to the gas valve is now shown. The dual solenoid boiler gas valve is represented here. The boiler gas valve is on the left of the gas manifold. The 24 volts to the pilot solenoid triggers gas to be sent to the boiler pilot assembly. At the same time the PV output was started, the spark was sent on the ignition wire to the igniter at the pilot assembly. The boiler pilot assembly is represented here. It is located beneath the boiler in the boiler burner assembly. The spark and gas arrive at the pilot, igniting a pilot flame, which contacts the flame sensor, generating microamps that are sent to the module on the sense wire. When the module senses the pilot, the spark stops and the module outputs 24 volts AC from MV3. On the diagram, the pilot flame is represented contacting the flame sensor. The flame sensor is mounted on the pilot assembly. The microamp sense signal is shown now on the diagram as it reaches the module, stopping the spark. And at the same time, the sense signal enables the MV output, which is sent to the relay board. The relay board also sends out a signal to enable the hot air pilot when the oven on signal is received at J1, pin 1. The hot air pilot enable output is sent to the cavity high limit. The cavity high limit is referred to as SW4 on the diagram, and it disables the hot air if the temperature in the oven cavity exceeds 671 degrees Fahrenheit. It is located behind the control panel on the right when viewed from the front, and the sensing bulb is down and to the left of the blower wheel. One example of how the cavity high limit may trip is if the gas valve main solenoid fails open, it could cause the burners to operate beyond the set point of the temperature controller. The high limit reaches 671 degrees trips, disabling the module. The gas valve is redundant. The gas is input and stepped down by the built-in regulator. Then voltage to PV opens the PV solenoid. This allows gas out to the pilot. When voltage is sent to MV, the MV solenoid opens and gas is sent to the main burner. It is very rare but possible for a solenoid to stick open when a valve fails. If the call for heat stops the voltage to MV but the solenoid sticks, the main burner gas does not stop. The high limit will stop the input to the module and PV voltage is ended. And when the PV valve closes, the main burner supply is stopped. In normal circumstances, when the temp control satisfies, MV voltage is disconnected, stopping the output to the main burner. Very infrequently, the pilot solenoid fails so that when the oven is turned to off or cool down and the relay board removes the voltage to the module and the gas valve, the PV solenoid sticks. The pilot output does not stop. It may diminish but not completely go out. The remaining pilot leaves rectification at the module even though there is no call for heat. When the call for heat returns, the self-check sequence at the module recognizes the pilot is lit prior to PV output and locks out the module. In this state, the module will not attempt to spark. When condemning an ignition module, to test for PV solenoid failure, disconnect terminal 4 sense. If this allows the module to spark but no spark is generated when attached, check for 100% closure at the PV solenoid. If the cavity high limit trips, the voltage is removed from the ignition module and sent back to the relay board to J4 pin 8. In normal operation, the cavity high limit sends voltage to the primary hot air